Hey guys, welcome back to AlgoYogi. We are doing two-pointer series, and our next problem in the list is partition array according to given pivot. So description is it's simple. Honestly, just a lot of bullshit, but it's simple. You are given a zero-indexed integer array nums and an integer pivot. Rearrange nums such that the following conditions are satisfied. What are the conditions? Every element less than pivot appears before every element greater than pivot, and in the middle it's pivot. Every element equal to pivot appears in between the elements. I mean, same thing. Come on, man. You don't have to tell us like that. And I think the relative order, we already know it. I'm sure you already read through the description. Okay, so I think it's really simple, and I think this problem might not even require two pointers. So what is it asking us to do? Very simple. This is our input array, and then we have this pivot element. In this case it's 10, and we have been asked to basically rearrange all the elements in such way that all the elements lesser than pivot element, which is pivot, is this. So this is pivot, and this is also pivot. Okay, there are two pivots, and then all the elements lesser than pivots are basically 5, 3, and 9, and all the elements greater than pivots are 12, 14, and that's it. So let's create our updated output, which will be 9 because we have to preserve the relative orders, and then it will be 5, and then it's gonna be 3, then it will be 10 and 10. First this 10, then this 10. Doesn't really matter though. And then we have the greater values than 10, which is 12 and 14, and that is, ladies and gentlemen, our output. Awesome. So how do we do it? We just create 3 different arrays and iterate over our original input and check if it is lesser than pivot. We store it in a different array, 3 different arrays, lesser, pivot, greater, and then finally we just combine them all and return that. That will be basically same amount of memory, big of n and big of n square, not n square, n time complexity. So I don't know, there are a couple of solutions around pivot thing. That's like quick sort kind of solution, and I don't know if they are using less amount of memory. Well, if they do, please comment. And I think this the solution that we are going to write is also quite straightforward and simple. And I think a lot of people like to do it this way as well. And I think it's kind of smart. Okay, it's like rather than catching your ear like this, you just simply catch it like this, you know. All right, so I'm gonna have three arrays, which first is lesser, and then I'm going to have pivot, and then I'm going to have greater. Okay, that's it. And for num in my nums, if num is lesser than pivot is an integer, by the way, so we add it to lesser dot append num if num is greater than pivot, then we append it to greater dot append num. Otherwise it will be pivot, and we just put it in the else case where we add it to pivot. And you know what, let's not just call it pivot, let's call it piv, because pivot is another variable name, which is the pivot number. So piv dot append pivot. Sorry, not pivot. Actually, that will also work. That will also work, you know? Why? Because num this time will be equal to pivot. And you know what? I'm gonna go with it. I'm gonna fucking go with it. You know, you don't have to follow the book rules, you know, of the book moves, whatever. And you return lesser plus piv plus greater. I hope I'm not missing anything or mistyping anything. Otherwise, this code, my guys, should work. Let's zoom out, and there might be some issue. I will fix it. Let's run it. Awesome, works. First go works. Medium problem, but it's actually really easy. All right, so let's write down the time complexity. Time complexity would be big of n, that's the number of elements, and space complexity is also big of n. We are storing that many elements. Also, we are using 3 different arrays, but still their length will, after, you know, we fill them up with the numbers, it will be same as nums. Okay, that's it. And I think there is a solution around how you might use 2 pointers, basically iterating from front and back, and then you have this another you have this new result array, which will basically take these values, which are first, you keep checking them. So I will track the values which are lesser than nums, lesser than pivot, and it keeps going this way, and this one keeps going backward, and then you keep filling up your result array, and then you just return it. But I think that also uses the same amount of memory. If I'm wrong, please do comment below. I want to see some comments because nobody's watching my videos. Who cares? I'm just having fun. Let's mark this one also solved. See you guys in the next problem. I don't know how many of you are watching, but I'm gonna go out for a run now. All right, might put some, I don't know. I think this is more like a therapy at this point. Well, bye.